Hello, math analysis. Welcome to our first lesson of the year, lesson P.1A, where we're going to be talking about real numbers. So when we're dealing with real numbers, a real number is just any number that can be written as a decimal. Amongst the real numbers that you would be familiar with, subsets of the real numbers would include the natural or counting numbers, the first numbers you've learned, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, forever and ever and ever. If you throw in 0 along with those guys, so 0, 1, 2, 3, 4, forever and ever and ever, for infinity, we're talking about the whole numbers. If we start including some negatives so that we can go forever and ever in both directions, from negative infinity till we get to -3, -2, -1, 0, 1, 2, 3, forever and ever to infinity, then we're talking about the integers. But of course, there's more to that than in our real number system. We also have rational numbers. Rational number is just any number that can be written as a ratio, also known as a fraction. So as a ratio, A to B or A over B, A divided by B, however you want to think of it, where A and B are both integers. Just remember that B cannot equal 0 because dividing by 0 is bad and sad, and we don't like that. Of course, rational numbers can be written as decimals, and when we do that, then they either become terminating decimals, a definite place where they end, or indefinitely repeating decimals. So 3, 3, 3, 3, 3, 3, 3, forever and ever and ever. You're familiar with these guys. Now, of course, you know of some real numbers, which any number that can be written as a decimal. You can think of decimal numbers that do not repeat and do not terminate, that go forever and ever and ever, but don't actually repeat themselves. They're real numbers too. They also have a place on the real number line. Probably the one most well known is our friend pi. We usually abbreviate it as 3.14, but of course we know that pi actually has a lot more digits than that. In fact, we've never found the end of it. It goes forever, never repeats. Weird square roots tend to do that too. Negative square root of 3 would be negative 1.73, blah, 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 blah. Goes forever and ever, doesn't repeat, doesn't terminate. So also a real number, not a rational number, but a real number, and he has a place on the real number line too. So everything to the right of 0 is, of course, a positive real number. Everything to the left of 0 is a negative real number, and 0 himself is neither positive nor negative. In fact, it's nothing. And some people question as to whether or not 0 is an actual number. That's a debate for another day, but, good times. Let's talk about our real numbers a little bit when we start comparing them. If we have any two numbers, A and B, you've seen these symbols before. The alligator always eats the bigger one. So we read this as A is greater than B. If we flip the symbol, it becomes A is less than B. If I put a line under the symbol, I think of it as a little squashed equal sign. So we say that A is greater than or equal to B. And of course, if we flip it, that means that A is less than or equal to B. And we know that these symbols are called inequality symbols. So I would like you to describe and graph this inequality. I'd like you to just verbally, or I guess you'd be writing it down, write down a description of what this inequality means, and then just draw a number line and graph this inequality. Hit pause to try the problem out, and then hit play when you're ready to check your work. So for this problem, I see that x is less than 3, so I would say that this inequality is all real numbers less than 3. Notice there's no equal sign, so it's just all real numbers less than 3. It doesn't actually include 3. So if I were to put this on a number line, it would be everything less than 3, but it does not include 3. Now, I used a parenthesis to indicate that. We'll get into more detail on that in a minute. But you may have used an open circle, a not colored in circle with your line going forever that way. Sorry for my bad mouse handwriting. Either way of writing it is totally okay. Your book tends to use that parenthesis symbol to indicate that it's open and that 3 is not included. So be aware of that. Now, let's say you've got numbers on both ends. Here I have a is less than or equal to x is less than or equal to b. So x is between a and b. So I get lazy as a mathematician and I don't always want to write out my inequality notation. So I will often write it in interval notation. Now, because it's closed at a, there's a squashed equal sign. I'm going to put a bracket right there, a nice square bracket. And you can see it's also closed at b. I put a nice little square bracket there. No squashed equal signs means it's open at A and at B. So I'm going to use open parentheses. So brackets mean it's closed. It means that both A and B are part of the interval. Parentheses means it's open. So while A and B are nice little markers, they are not actually part of our interval. X cannot be A or B, just everything in between. And of course, you can mix it up a little bit. You can see in this case, it's closed at A, it's open at B, or you can switch around. It's open at A, it's closed at B. And of course, A and B are just the endpoints of our interval. In this case, B is part of the interval, but A is not. In this case, A is part of the interval and B is not. So you really got to watch whether you've got a bracket or a parenthesis there. It makes a difference. Of course, we know that sometimes you don't have both ends, but sometimes you just have x is greater than or equal to a. Well, I see the equal sign, so I know it's closed at a, and I know x is everything greater than a, so I know it's going to go up and up forever and ever and ever toward infinity. So I'm going to say it's closed at a, and it heads toward infinity. Infinity always has an open parenthesis. Always, always, always. This one does not have a squashed equal sign, but we still see x is greater than a. So I'm going to put an open parenthesis at a, and again, heading toward infinity with that open parenthesis. If we go the other way, though, I can see that x is less than or equal to b, so I know that means it's going to be a closed bracket at b. And I can see that x is everything less than b, so I'm not actually going toward infinity this time, I'm going toward negative infinity. So I start at negative infinity, always open at infinity, and up to closed at b. And this one does not have an equal sign, so same idea, open at negative infinity, but now it's open at b as well. And notice in this case, each of these intervals has exactly one endpoint, and it goes forever and ever in one direction, not both, namely A or B. So here's what I would like you to do. I would like you to take this interval notation that I have here, and I would like you to first write it as an inequality, and then second, make a number line, graph the interval. Again, hit pause to try it out, and then hit play when you're ready to check your work. So you can see that it's closed at -6, so I know it's going to be a squashed equal sign on the -6 side, and it's open at 3, so no squashed equal sign over there. So my inequality looks like -6 is less than or equal to x is less than 3. And that means when I graph it, I'm going to put a closed bracket at 6 on my number line. I'm going to put an open bracket at 3 on my number line, and of course, color in between because it's everything between -6 and 3. It includes -6, does not include 3. Again, if you did it such that you had a closed colored in circle here and an open circle here, and you colored in all the bits in between, that's okay. Just keep in mind that your book uses a bracket for closed, a parenthesis for open. So I hope that was helpful. You know that you can email me if you got any questions or concerns. You also know that I'm around Tuesdays and Thursdays after school. Come on down if you need help, and I'll see you soon. Bye.